Hi students, the second half of 10.5 is about horizontal stretches. And I just realized, looking at this, that that should say 10.5b. This is the second half of 10.5. So we're still doing compressions and stretches, but this time we're going to push away and towards the y-axis rather than the x-axis, because that would be a horizontal movement. So here's an example from the book. This is a quadratic. The blue function is f of x squared. F of x equals x squared. And then the red function multiplies x by a half before it squares it. This is different from what we were doing yesterday, because what we were doing yesterday was we were squaring first and then multiplying by a half. So the visualization of this motion is going to be away from the x-axis. We're pushing this blue graph away from the x-axis. Y-axis, away from the y-axis, because it's a horizontal change. This is when our k value is a fraction or a decimal, less than 1. It could be positive or negative. If it's negative, it actually would, for this particular one, it would still be the same. So it's pushing it away from the y-axis. This is an example that the book gave that I thought was a little bit hard to visualize. F of x is the quantity of x plus 1 squared, so that's a quadratic that's been shifted sideways in the negative direction, 1 unit. And then g of x is the same function except that x has been multiplied by 2 first. And that, because 2 is bigger than 1, that's going to be a compression towards the y-axis. I'm actually going to pull up a Desmos graph to show this better, because I think that seeing it in action helps kind of see how that works. So here's a Desmos graph. If I move k, so right now k is set to 1, so that's exactly the same function because I'm multiplying by 1. Now I'm going to make k bigger, and notice how that's pushing my whole graph, compressing my whole graph towards the y-axis. Everything is getting shifted and compressed towards the y-axis. If I make k less than 1, then that pushes my graph away from the y-axis, stretching it away from the y-axis. Isla wants to introduce herself. She's standing right here.
Hello, my name is Ayla, and the mama is my mama.
All right. So we can also change this function so that it's something else. Like we could make this let's make it the absolute value function. Let's look at just the absolute value of x. I didn't make this dependent on f, so I'm going to make it look more like what I have in the notes, where I have f of k times x. And as I slide this k value so that it's less than 1, notice how it's pushing it away from the y-axis. And as I make k bigger than 1, it's pulling it or compressing it towards the y-axis. And this is, so that's the change. We're multiplying by a number first, and then we're plugging it into the function, and that is pushing it or pulling it away from the y-axis. If I again make this a plus 1, I really want to stress that this is having to do with the y-axis, not the x-axis. If I change it so that I do it like we did yesterday, which would be a horizontal a horizontal compression or stretch, that is pulling it towards the x-axis. You see that? But if I move it so that it's inside the parentheses, now it's stretching it, now it's being pulled by the y-axis. So that's really the big difference between yesterday and today. It's where this multiplier is. Today we're going to multiply first and then plug it into the function. Yesterday we were plugging it into the function and then multiplying. And when you do it that way, that is a vertical stretch towards the x-axis or away from the x-axis. When you put it inside of the parentheses, you do it to the x first and then you apply the function. That's going to be a stretch towards the y-axis or away from the y-axis. Okay. So here's what I would write in your notes. How does multiplying the input by a k that's small, a fraction or a decimal, change the function? And if you multiply the input by that k, then that's going to stretch your graph away from the y-axis rather than the x-axis. Please pause the video so you can write that down. And then I'm going to ask you to put an example in your notes, some sort of example of that in your notes. You could use the ones that I showed on Desmos. You could use your own example, but make a picture of what that looks like. The example that I used, because I'm really familiar with quadratics, is I drew a picture of x squared. So that's f of x. And then I drew in a different color, because I'm fancy like that. I drew a picture of g of x, which I'm going to call, let's say, 1/2 x squared. And that one is going to be pushed away from the y-axis. So it's going to be pushed away from the y-axis. And then I even drew arrows showing that it's pushing away from the y-axis. And the other half of this is if we multiply by something bigger than 1, then that's going to be a compression towards the y-axis. So that's going to pull it towards the y-axis. And take a minute and pause me and go ahead and write that down. And when you've got that written down, also sketch an example of what that looks like so that you have an example of that as well. Here are the notes that I have for today. I guess you can't really see the top of it. I'll scan up a little bit so you can. So I have 10.5b, which are compressions and stretches, horizontal ones. And then I have the if-then statements, and I also have examples below each one. So those were my notes for today. I have a little summary. I'm going to scan back down, pan back down. So here's a summary. We talked about vertical stretches or compressions. So a vertical stretch is when you multiply the output by k, so you're multiplying the whole function by k. If you multiply by a big number, that pushes your graph away from the x-axis. If you multiply by a fraction or a decimal, that pulls it towards the x-axis. And then horizontal ones are when you're multiplying your input by k, and here we have a small k, so that's going to push your graph away from the y-axis. So that's the summary for this whole unit. Good luck on homework tonight.